Subscribe my channel for physics, GE and NEET.
Hello students, good morning all of you. So this is the second lecture on the center of mass. So yesterday we are discussing about the center of mass between two particle system or two or more particle system. So but today we are discussing some numericals to find the center of mass, and also in case of some concepts, sphere and some discs and uniform rods, they are contact to each other, how we can find the center of mass, So before going to learn that, so you have to subscribe my channel and like, share to your friends. Okay, thank you. So let us start our topic. So the center of mass for the two or more particles, it is equal xcm, it is equal m1x1 plus m2x2 plus up to mnxn, whereas n number of particles are located in the system, and here the total mass, it is the m1 plus m2 plus up to mn, right? So this is the center of mass of the system having n number of particles in a system. If two number of particles are there, we have to take m1 plus m2 up to this one. If three number of particles are there, so m3 along with this m3 x3 by m3, right? If four number of particles are there, so like this. So this is the formula to find the center of mass. So this formula is explained in our previous video. I will be giving our iCards, you have to see, check, right? So let us see how we can find the center of mass of an more number of particles. So here the question it is three objects 1 kg, 2 kg, 3 kg are arranged at the corners of a triangle, of 1 meter a side, or 1 meter each side, Now find center of mass of the triangle, center of mass of the system. So how we can find the center of mass of the system? So here the condition is 1 kg is at the origin, right? 2 kg is at on the x-axis, so remaining it is the xy plane, clear, right? So here this is the x and y axis, we have to take, so this is x-axis and this is y-axis, this is the origin point. At an origin m1 it is equal 1 kg is here, this is the 1 kg, right? And this is the 2 kg, where m2 it is equal 2 kg, and so this is the m3 where it is equal 3 kg. These three particles are arranged in the equilateral triangle. Okay, so the coordinates of at this point, it is 0, 0, clear, because of this is the origin. So the distance of the side, the length of the side is, each side is 1 meter. Okay, so from this, at this point the coordinates are here, the distance, this is the triangle, let it be ABC. The triangle ABC, AB side is the 1 meter, AC side is 1 meter, BC side is also 1 meter, right? So here from A to B there is 1 meter, and on x-axis it is y component is equal 0. X comma y. So here also x comma y. So how we can find this one? The distance from the x-axis, so here it is the, whereas midpoint of this one, so that is 1 half of the 1 meter, that is 1 by 2 meter. So here the x component is the 1 by 2. So here this is the equilateral triangle. In the equilateral triangle, one angle is, it is equal 60 degrees must be is equal 30. So let me have to find that. Here it is root 3 by 2. Root 3 by 2. So this is x1 y1. It is x1 y1, x2 y2, whereas x3 y3. Okay. So now let us find xcm and also ycm. Xcm it is equal m1 x1 plus m2 x2 plus up to m3 x3. So there are three number of particles are there, that is m1 plus m2 plus m3. So here let us write m1 x1. What is m1 here? m1 it is the 1 kg and x1 it is the 0 plus m2 it is the 2 kg, x2 it is the 1 and plus m3 it is the 3 kg, x3 it is the 1 by 2, whereas the total mass here it is equal 1 plus 2 plus 3. Clear? So let us substitute here, whereas 0 plus 2 plus 3 by 2, 2 plus 3 by 2 by 6, it is 1 plus 2 plus 3, it is equal 6. You have to write that 4 plus 3, it is 7 by 2. 7 by 2 into 6, it is equal 7 by 12. So x centimeter is equal x cm, it is equal the center of mass along with the x axis, it is the 7 by 12. Now find the ycm. According to the y axis, so it is m1 y1 plus m2 y2 and plus m3 y3 by m1 plus m2 plus m3 here. Okay, so let us substitute m1 it is the 1, y1 it is the 0, 1 into m1 into 1 into 0, 0 and m2 it is the 2 and y2 is the 0, it is also 0, where is only m3 it is the 3 kg and y3 it is the root 3 by 2, root 3 by 2 here and by what is 6, m1 plus m2 plus m2. So now let us write where ycm it is equal, how we can write that, root 3 by 2 into 6, 2 into 6. So 3 twos are root 3 by 4 here. ycm it is equal root 3 by 4. So now the center of mass of coordinates, the center of mass coordinates are center of mass. It is xcm comma ycm is equal. What is that? Xcm it is the 7 by 12 and ycm it is the root 3 by 4. So this is the center of mass we have to find here. This is the method we have to find the center of mass of three corners of a side of the triangle. Three objects are located at the three corners of the triangle. If four particles of different objects, different masses are located in the corners of a square, then also we have to find the center of mass. Okay, let us see how we can find in case of square. Okay, clear? Let us note it. Now let us see how we can find the center of mass of a square if four particles are arranged in the four corners of a square. So here 1 kg, 2 kg, 3 kg and 4 kg particles are arranged four corners of a square, four corners of a square, each side 1 meter. Find center of mass of the square. So here how we can find the center of mass of the square, let us see. So here this is the four corners which are right. This is the x-axis and this is the y-axis here. So here this is the origin, which is the first massive particle m1 is equal 1 kg is located. From this point at the 1 meter of distance, so each side is 1 meter. There is a point, it is the 2 kg. And from this 1 meter, there is another mass, that is m3 is equal 3 kg. So here m4 it is equal 4 kg. So here these are the four corners of a square. Four corners of the square, each side is 1 meter. Now let us write the coordinates of the each mass. So here this is the 0, 0 coordinate because of it located at the origin. From the 1 meter of distance, here x coordinate is the 1 meter and y coordinate is the 0 here. From this to this one, it is the 1 meter. From this to this point, it is the 1 meter. There x comma y it is 1 comma 1. And from this one to this one 1 meter, here x coordinate is x coordinate. So here this is x axis and this is y axis, and the x coordinate here it is the 0 and y coordinate this is the y axis 1 meter. Okay, right. So these are the x1, y1, x2, y2, x3, y3 and x4, y4. So let us find simply xcm and ycm here. So there is xcm, it is equal, here you can write that xcm is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. Right, let us substitute all those values here. M1 is 1 kg, x1 is the 0, plus m2 is 2 kg, x2 is the 1, and plus m3 is the 3 kg, x3 is the 1, and plus m4 is the 4 kg, x4 is the 0. Here m1 plus m2 plus m3 plus m4, 1 plus 2 3, 3 plus 3 6 plus 4 10 kg. So here 2 into 1 2 plus 3, this is 0 and this is 0. So 2 plus 3 is equal 5 by 10, it is equal to 1 by 2, it is equal 0.5 meter. So this is the xcm here. Clear? Now let us see ycm. So in case of ycm, we have to find ycm, it is equal m1 y1 plus m2 y2 and plus m3 y3 and plus m4 y4 by total mass, it is the m1 plus m2 plus m3 plus m4. Okay, let us substitute all the values here. M1 is the 1 kg, y1 is the 0 here, and similarly m2 is the 2 kg into y2 is the 0, and plus m3 is the 3 kg into y3 is the 1, and plus m4 is the 4 kg, y4 is the 1. Let us the total mass, it is equal to 10 kg. Here 0 0, 3 into 1 3 and plus 4 7 by 10 is equal 0.7 meter. So this is the ycm here. So the center of mass of coordinates, here, it is equal xcm comma ycm is equal 0.5 meter comma 0.7 meter. So this is the process. You have to find the center of mass of any particles. It means how many particles are located at the corners of a triangle or the square. Then we have to find easily the center of mass of that system. Okay, clear? Okay. Now let us see one more example. We have to find the center of mass of velocity, and the center of mass of acceleration. So how we can find that? Let us see. If two particles are moving the same direction, if two masses are moving with the same direction, then how we can find the velocity of the center of mass? Here, that is 2 kg, 4 kg masses are moves in the same direction, in the same direction with the speed of 5 meter per second and 10 meter per second. Let's find center of mass of velocity. Center of mass of velocity. Okay. So how we can find the center of mass of the velocity? The center of mass of velocity VCM, it is equal m1v1 plus m2v2 by m1 plus m2 here. Clear? Whereas m1 it is equal to 2 kg and v1 is the 5 meter per second plus m2 is the 4 kg and v2 is the 10 meter per second. v2 is the 10 meter per second by m1 plus m2. It is equal 10 plus 40 by 6. 50 by 6. 50 by 6. Here there are 8.3 meter per second here. So this is the VCM. So here if the two masses are moving in opposite direction, if they are moving in opposite direction, then what we can do? So if they are moving in opposite direction, so if they are in opposite direction, so how we can find the center of mass of velocity? Whereas XCM it is equal, VCM is equal m1v1 minus m2v2. So because of the velocities of the two masses are opposite. So there is m1 plus m2 here. So now let us, here there is minus. It is 10 minus, what is that? 40 by how much? 6. It is equal 30 by 6. It is equal minus 5 meter per second. So this is the VCM if they are opposite direction. If they are in same direction, this is the center of mass of velocity. If they are in opposite direction, that is the center of mass of velocity. Now let us find one more example to find the center of mass of acceleration. So how we can find the center of mass of acceleration of a system? So here, if two identical masses, identical means equal, same, identical masses, if two identical masses are locates on x-axis, first one is at rest and another is accelerates A. Find center of mass of acceleration of the system. So now let us see how we can find. So here there is an axis which is the first particle is at rest, the acceleration is 0. The second particle is locates on the x-axis with an accelerates A. So this is the whereas two identical particles, the masses of m1 is equal to m2 is equal to m. Where a1 is equal to 0, a2 is equal to a. So therefore ACM is equal m1a1 plus m2a2 by m1 plus m2 here. So now let us see, m1 is m, a is 0, a1 is 0 plus m2 is m, a2 is equal to a by m plus m 2m. It is ma by 2m cancel, it is the a by 2, ACM it is the a by 2. So this is the center of mass of acceleration of the system. Clear? Okay. Now let us see in different concepts in case of that is spherical disc and spheres. How we can find the center of mass of spheres and discs are contact to each other. Spheres and discs are contact to each other. So if there is a two discs of same material having thickness T and density rho they are in contact to each other. Find center of mass. Very important, right? So how we can find? So here there is a circular disc which can having the radius of r1, right? Here one more circular disc is there, that is the center of mass here, which is r2. Okay, so here the mass we have to find m1 is equal how much and m2 it is equal how much. So they have been given to us, that is density and thickness. The density of the disc it is equal rho, density of the disc rho is equal to mass by volume. So mass it is equal density into volume. Volume of the disc is equal, what is the volume of the disc? Pi r square t. Here t for thickness. Therefore mass it is equal pi r square rho t. So rho into v. V it is the pi r square t. This is the mass. So now we have to find the mass m1. It is equal, from this you can write that pi r1 square, where it is rho t, because of rho is the same for each disc, because the material is same and thickness is also same for both discs. And the m2 is equal, you can write that phi r2 square rho t. So these are the masses here. And to find the center of mass, where it is xcm, it is equal to m1 x1 plus m2 x2 by m1 plus m2. So where how we can find the x1 and x2? So this is the x1 here, whereas 0, this is the origin we have to find. And here x2 y2 of course. So x2 it is the r1 plus r2. So there x1 is equal, you can write that here, you can write x1 is equal 0, x2 is equal to r1 plus r2 here. Let us substitute here from m1. What is m1 here? Phi r1 square rho t x1 0 plus phi r2 square rho t r1 plus r2 by m1 plus m2. What is m1 here? Pi r1 square rho t plus phi r2 square rho t here. So which is constant? Let us common here. Then we have to solve this. This is 0. Phi r2 square rho t into r1 plus r2 by phi rho t is common, whereas r1 square plus r2 square. Okay, so here phi rho t and phi cancelled out. It is equal to r2 square into r1 plus r2 by r1 square plus r2 square. So this is the center of mass of the two discs, center of mass of the two circular discs, which are made up of same material, that is having the density rho and the thickness t, which they are contact to each other. Okay, so this is the center of mass of the disc, center of mass of the two discs which they are in contact. Now let us see if the two circular spheres, this is the disc meaning that, so here this is the entire, there is a overlapped by the mass, so here there is no halo, so the total mass, the total surface is allocated by the mass of, that is the disc. Okay, now let us see application 2. In case of two spheres are contact to each other, which they are made up of same material, okay, so how we can find that? Let us see. Right, so this is the application 2 here. Application 2, whereas two circular discs, two circular spheres are made up of same material, having density rho, and find and contact to each other, then find center of mass, okay. So in previous we have to discuss about the two discs are contact to each other. Now we have to discuss about the two circular spheres are contact to each other. So this is the sphere, which you have to contact. So this is one of the sphere having the radius r1, and one more sphere which is contact to the first sphere. So this is the another sphere having the radius r2. Okay, so now how we can find the masses of the sphere m1 and m2. Okay, so the density of the sphere rho it is equal to mass by volume. Here volume of the sphere it is equal 4 by 3, it is equal pi r cube, 4 by 3 pi r cube. Okay, so let us write the volume of the sphere here 4 by 3 pi r cube, whereas pi r cube. Then we have to find the mass, it is equal to density into volume. So 4 by 3 pi r cube into rho. So this is the mass of the particle in this. So from this you can write that m1 is equal, how we can write m1 is equal 4 by 3 pi r1 cube rho. Because of rho is constant for the both the spheres, it can made up of same material, r2 cube rho. So whereas x1 it is equal 0 here, and x2 it is equal r1 plus r2 here. Clear? And now let us find the center of mass. Xcm, it is equal to m1x1 and plus m2x2 by m1 plus m2 here, which is nothing but m1 it is equal to x1 is equal to 0. Let us cancel out this one, and m2 is equal to 4 by 3 pi r2 cube rho plus r1 plus r2 by 4 by 3 pi r1 cube rho plus 4 by 3 pi r2 cube rho, which is common here, 4 by 3 pi rho, 4 by 3 pi rho. So here it is 4 by 3 pi rho into r2 cube r1 plus r2 by 4 by 3 rho pi, 4 by 3 rho pi, here r1 cube plus r2 cube is the common. So these two terms are cancelled out. It is equal to r2 cube r1 plus r2 by then r1 cube plus r2 cube. So this is the center of mass of the two spheres which they are contact to each other, which are made up of same material. So what is the difference you have to observe here with the between sphere and to the disc? This is the sphere here. So sphere means a short put, you know very well, short put. So that is the sphere. Disc means discus throw, disc which is overlapped by the total surface of mass, right? So the main difference it is the, in case of this is the sphere, in case of disc xcm it is the we are replacing by the r2 square only. Here there is cube, so r1 plus r2 and plus r1 square plus r2 square, simple. So this is for the disc and this is for the sphere. So how we can find the mass where they can given to us density? That is the main important you have to learn here. Okay, without giving the mass, we have to find the mass by the using of the density and the volume, right? And one more we have to see here. If there are two uniform rods, application 3, which is two uniform rods are connects. If two uniform rods are connected in the shape of T, so that is application 3, which is application 3. If two uniform rods having length what is that, L1 and L2 are arranged in the shape of T, then find center of mass. Of the system. So two uniform rods are there. So this is the first uniform rod. Which is having the L1 length, and one more uniform rod it is. So this is the first uniform rod. Okay, and here one more uniform rod is that we have to arrange with the shape of T. So this is the length having L2 here. The center of mass for the first rod it is the L1 by 2. The center of mass for second rod it is the L2 by 2. Okay. So here this is the 2 points where here x1 it is we have to write 0 and x2 we have to write x2. What is that x2? L2 by 2. So here you can write that. So x1 it is equal 0, x2 it is equal what is that? L2 by 2. Okay. So how we can find mass? The density of the uniform rod, density rho, it is equal to mass per unit length. Mass per unit length. In case of uniform rod, length will be taken as by the replacing of volume. So therefore mass it is equal to density into length. So mass m1 it is equal to rho into L1. Rho into L1. So rho is constant for the two rods because of it. They are the uniform rods. Okay. And from this you can write m2 is equal rho into L2. Okay. So let us find xcm, it is equal m1x1 plus m2x2 by m1 plus m2 here. This is equal m1 it is equal, what is that m1? Rho L1. x1 is equal 0 plus m2 is equal rho L2. x2 is equal, what is that? L2 by 2 here by m1 plus m2. Rho L1 plus rho L2. Let us simplify. This is 0 and rho L2 square by 2. Rho into L2 square by 2. Okay, by, so 2 will be comes, so it is equal to 2 into rho will be common L1 plus L2 here. So rho gets cancelled, L2 square by 2 into L1 plus L2. So this is the center of mass of this combination, this arrangement. Okay, one more important you have to note here. If two rods having the same length, L1 is equal to L2 is equal to L, then what is the center of mass? If two rods are having the same length, whereas xcm it is equal, let us substitute L2 square it is equal to L square by 2 into L1 plus L2, L plus L, it is equal to L square by 2 into 2L. This is square and L cancelled, it is L by 4. Where xcm it is equal L by 4 if two rods are having the same length. If two rods are having the same length, then the center of mass will be located at this point. So from this one to this one there is L by 2, L by 2, and from this one to this one there is the L by 4. So here this is the meaning where at the L by 4 distance the center of mass is located in this case. Clear? So this is very important application you have to learn for doing the more applications. Okay. So let us see one more. That is nothing but where two cylindrical rods are connected to one end to another. Two cylindrical rods. So let us see. If two cylindrical rods are connecting one end to another, then find the center of mass of the system. So how we can find? So that is, you can find that so two cylindrical rods. Two cylindrical rods are connects one end to other, have same density, then find center of mass. Now here two cylindrical rods which are connects as follows. This is one of the rod, one of the cylindrical rod, and having the length L1, and this is the another cylindrical rod which is having the length L2. Okay, the radius of the first cylinder, it is R1. The radius of the second cylinder, which is arc. Okay, the center of mass, this is the C1 here, nothing but at the point of L1 by 2. The center of mass of the second rod, that is L2 by 2. This is C2. Okay, so here this is the distance between the center of masses of the two cylinders, two cylindrical rods. So here x1 it is equal 0, this is the origin, and x2 it is equal, what is that, L1 by 2 plus L2 by 2. So this is the L1 by 2 and this is the L2 by 2. L1 by 2 plus L2 by 2 here. Okay, now find the masses. So this is the M1, how much, M2, how much. So mass it is equal volume into density. Volume of the cylinder, it is equal 5 r square L, and therefore mass M, it is equal 5 r square L into rho. So this is the mass. From this equation you can find the mass of the first cylinder and mass of the second cylinder. Whereas mass of the first cylinder is equal 5 r1 square L1 rho. Similarly, mass of the second cylinder M2 is equal 5 R2 square L2 rho. So now let us find the center of mass. It is equal, XCM it is equal M1x1 plus M2x2 by M1 plus M2. It is equal, what is M1 here? X1 is equal 0, so M1 term will be 0 here. M2, it is meaning that 5 R2 square L2 rho into, what is X2 here? L1 by 2 plus L2 by 2 here. Clear? And now we have to write by M1 plus M2 by M1 plus M2. What is M1 here? M1 is the pi R1 square L1 rho plus pi R2 square L2 rho here. So which is common here? Pi rho. Pi rho is the common. Where you can write R2 square L2 by pi rho is common here. It is R1 square L1 plus R2 square L2 into, so this one L1 by 2 plus L2 by 2 here. Okay, so let us cancel each other, and then this is the center of mass of the two cylindrical rods are connects in one end to another. Okay, so that is how we can simplify that here. It is, we have to write where XCM it is equal R2 square L2 by here you can write L1 plus L2 also, L1 plus L2, whereas 2 is the LCM here. 2 into R1 square L1 plus R2 square L2. So this is also the equation which you have to simplify that. So here 2 is the LCM, so then L1 plus L2 by 2. This 2 is multiplied by this denominator term, that is the center of mass of the, if two cylindrical rods are connects each other, each one into another, then the center of mass. Okay, clear? Now let us see one more. So here, if a straight wire if a straight wire which is bent in the shape of a circle, which is bent in the shape of a circle, then find the shift of the center of mass. Shift of the center of mass. So this is application 5, which is if a wire, a straight wire is having the length L. So the center of mass is located at O. So this is bent in the shape of circle. So these two ends are bent this side in this way. The two ends are bent. So then the center of mass should be, so it can be bending. So then in the shape of circle. So this is the circle which you have to bend. So then the center of mass is shifting to this point. This is the O here. Okay. So now the length of the wire should be here. L is equal, what is that? 2 pi r here. So this is the radius of r. So at first the length, it is the straight wire. It can be bent in the form of circle. Then the center of mass should be shifted to this point. So this is the x. The x, it is the shifting of the center of mass. So where x it is equal r always. X is equal r. So the shift in the center of mass, it is equal L, it is equal 2 pi x, where x it is equal L by 2 pi. So this is the shift in the center of mass. L is equal 2 pi. This is the shift in the center of mass. Okay. What is the shift in the center of mass? That is x it is equal L by 2 pi. L by 2 pi. Clear? Right. And one more here we have to see. So if a uniform rod, so this is application 6. If a uniform rod is there, so this uniform rod is bent from the half of the length. So if a uniform rod is, for suppose this is having the length L, this is bending from the half of the length. So then this length will be bending. So in this direction. Right? So now this is the L by 2. L by 2 here. And these two are L by 2 and L by 2. These two are L by 2 and L by 2. Now the center of mass, shift in the center of mass here. Shift in the center of mass. At first the center of mass is L by 2. And now the shift it is, this is the center of mass and this is the center of mass here. Okay. So the center of mass, it is equal, how much here? L by 4. L by 2 by 2. So this is L by 2. And at the center L by 2 by 2. This is center of L by 4. It is L by 4. So here at first whenever you have to bend, that is theta. So for the center of mass of this point where you have to measure, that is the here theta by 2. Okay. So for the here the center of mass xcm, it is equal along with the x-axis, that is a horizontal component where you have to write how much the distance, it is L by 4 into cos theta by 2. L by 4 into cos theta by 2. If theta is equal 90 degrees, then the length, so this is the at first length L having the center of mass at L by 2. If theta is equal 90, it means it is bent in the direction of perpendicular. So this is the 90 degrees. So then what is the center of mass here? If 90 degrees it is here, L by 4 cos 90 means 90 by 2. It is equal cos 45. L by 4 cos 45. Right? So this is the xcm here. Right? If theta is equal 0, then what will happen? Theta is equal 0 means it will be So same as parallel. So therefore axiom it is equal the center of mass L by 4 cos 0 it is equal to 1. So at the center of mass it is equal at L by 4. Okay, cos 0 by 2 it is equal to 0, cos 0 is equal to 1, center of mass it is equal at L by 4. At this point the center of mass is located. Clear? So these are all the applications we have to find the center of mass in different patterns. Okay, so I hope you are understanding very well. If you like this video, please share to your friends and do not forget to subscribe my channel. So please cooperate me and please push up my channel and please share to your friends. If you have any doubts, please ask me in the comment sections. Bye.